What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live stream where we try to write something cool from scratch, usually with the language C or with my new language Mesh, and just see what we can accomplish in the span of about 2 hours. Let me crank this music down slightly. I keep tweaking the volume, and then later I regret it. So anyway, today the goal is to try and build the foundation of an entity component system for the game engine that we started working on. So if you didn't see the last stream or two, what I said was that in March, we're going to spend some time trying to build a game from scratch, mainly as a way to sort of validate some of the tooling that I've been working on so far, the graphics code that we have been writing for Flux Compose and the Mesh language itself, to see if we can actually ship a basic game with it, or the foundations of a basic game with it in the lead up to the Ludum Dare game jam on April 1st. So my goal is to be able to produce tools that I can use to write a game in a weekend, basically, for that competition. Obviously, that's going to be difficult, but that's part of the fun. It's just, try to see if we can get there and what we can do with it. So today we're going to be working on some of the more design aspects of the game engine. Maybe you've heard of Entity Component System before. We'll talk about that a little bit more in a second, but it's pretty cool. It's a pretty cool idea, I think. So update since last time. So in the last stream at the very end, we went from 0 to having a basic game engine code base and having stuff rendering to the screen, or I guess the screen was being cleared the appropriate color, but we could not get the texture to render correctly. Turns out, as always, it was just a simple issue where I wasn't setting the right shader program ID whenever I was drawing. It's a ghost of a bad design decision that has bitten me once again. I'll probably change that design now that I've seen this happen multiple times. But now that's working, so we actually do have a basic sprite rendering on the screen, as well as the screen clearing that we saw the last time. So we do have the basis for working on game code, which is why we're going to start doing some of that today. Also, I spent some time reorganizing and renaming a bunch of code in the code that we started in the last stream, since we basically just really quickly copied a bunch of code over from Flux Compose to get the basis of a project started. I went back and reorganized the files, renamed some things, and got the APIs looking a little bit more like what I want them to be. So I'm a bit more happy with that. Hello to Daigo and to Jackson. Thanks for being here. So let me, actually, let's do this. I'll jump over to the code really quickly just to give a high level overview. So I had a bunch of files in the crash subfolder of crash the stack/source. That folder is gone now because a lot of the stuff has been moved into the Substratic folder. The reason why is because the Substratic engine, or I guess the set of APIs there, will eventually be extracted into its own repository. So I'm trying to factor out all this code to make it possible to reuse it in the game we'll do on April 1st, whatever that ends up being. But we need to make sure we can have this as a separate library for that purpose. So a lot of stuff I just moved around to different files. The render.c is basically what used to be graphics.c, but then the window parts of that have been pulled out now to window.c. So we've been able to separate those two concepts to the point where now if you look at the main.msc file for the game, we create a window, but then we create a renderer based on that window, and that renderer is what we're using from that point forward for rendering anything. So we have render APIs for clearing the screen, for drawing textures, swapping the buffers, etc. So that gives you the sort of low-level control over the render process, I guess you could say. And now we're not using window as a terminology for encapsulating the thing that you're rendering to. So it's a little bit more clean, in my opinion. So I'm happy with this as a starting point, and that's where we're going to move forward from today. Also did a little, cleanup on something like in the main.c file. I had this big block where I was registering the native functions that go into various Substratic modules, and now I've sort of broken that out into individual init functions for the different modules, so that hello, Robert, so that you can manage those native function registrations in the individual modules themselves and not have the code spread all over the place. So this feels a bit more clean now. So I think we're in a really good spot to continue working on the actual design of everything today. I'm very excited about that. All right, so today we're going to be sketching out the initial design of an entity component system written in Mesh. We're going to try to write as much of this as possible in the Mesh language with the features that I've written there so far. So if you don't know what an entity component system is, let's grab this. What did I just do? Okay. Wikipedia. I cannot type right now. Wikipedia entity component system. You're probably wondering why I didn't just click that link. It's because it's going to open up Qt browser, and Qt browser is broken right now. All right. So this says an ECS, or Entity Component System, is a software architectural pattern used mostly on video game development for the storage of game world objects. An ECS follows the pattern of entities with components of data. So it favors composition over inheritance. So if you know about object-oriented programming, typically in an object-oriented programming style, you have a class hierarchy where you have some base game object class and you're making inherited classes from that for different specializations of behavior. In an entity component system, instead, you break out all the behavior into individual components that can be used interchangeably, and a single game object is really just a container sort of conceptually for a set of components that give it unique behavior. And the components themselves have data that go along with them. Then this whole system part is what actually gives functionality to these components, where a system is a piece of code that will execute the behavior necessary for those components. So basically the goal is to break down monolithic game object implementations into a more composable design. So as I mentioned before, an entity is basically just a game object, but really in more modern entity component system implementations, it's just an ID. So it's just a number that says what the index of the entity is. All of the actual component data is stored elsewhere. So a component is just the data for an entity that a particular system understands. And you'll typically have lists of a single type of component that are stored contiguously in memory and sort of managed separately than other components. And then the system is just the actual code that implements a particular behavior across a collection of a single component type. So if you had a component that represents what could be rendered to the screen, you may have a system that can take all the components that have renderable, or all the entities with renderable components, and then render out their stuff to the screen. So what's nice about this? Well, you're basically decoupling game objects from behavior, which means that you can mix and match behavior more effectively in a game. It's also easier to test certain parts of your, well, when I say test, I mean like play test, not necessarily unit test, but it could be easier to unit test too. But it's easier to try out different things or experiment. You don't have to have, code that has to be continually refactored. You just switch out components that you want to use for particular purposes. Also, an interesting aspect of this is that systems can be executed at any time, even on different threads. So a typical game loop is very tightly bound on, you update the controllers or any kind of external input sources, then you update all the game objects, then you render all the game objects. And you have that sort of as a continuous loop. With systems, certain systems or certain types of components can be updated like maybe every minute, or it could be every other frame, or it could be on a separate thread running continuously. So anything can be done like that, and it gives you the ability to have even more control over the parallelism of your code and even when things happen. So you can do more advanced functionality with that. Also, it enables much better performance whenever your component data is organized appropriately in memory, particularly with the principles of data-oriented design. So if you can have contiguous arrays of structs in memory in C, then it's much easier to get the benefits of cache accesses in your CPU, because all that data is sort of next to each other. And typically a system is going to be iterating over everything, every instance of a component of that particular type. So you can really quickly just iterate over everything, do all the processing you need to do, and get a lot of benefits from that. Excuse me. So that's something that we can't really do as easily right now because of the way that the language is designed, but I'm going to add some features to it pretty soon that will make that easier. Hello, Camelo. Hey peeps, hey David, didn't know this channel of yours until recently, liking the variety even though game dev isn't my cup of tea. Well, hopefully it will be interesting to see things come online even if game dev isn't something that you are interested in on your own. All right, so what we're gonna do is start with a simple design for an entity component system in Mesh using the features we have so far in the language, and then we'll improve it as we go on future streams. But right now we're just gonna try to do sort of the basics to get it working, and then we can start building using that for all the game functionality that we would want to add. So our tasks for the day. First of all, we got to do one more fundamental task before we can get into the fun stuff. which is we need to add an object array type to mesh. So right now, the only type for collections is really just a list type, which is effectively a linked list. But to have a slightly faster access to that, or to a collection of objects, I would like to have an array that can be resizable, more like a vector, I guess. But I don't know. I'm not sure yet whether I call it vector or list. Hey, 3 times 0. So we'll rename it if we decide to. But for now, I'm just going to call it object array. But basically, that will give us the ability to have a contiguous array of values in memory that point to objects, but those objects are still allocated somewhere else on the heap. So it's not the ultimate in performance, but it's better than just having linked lists all over the place. And after we have that type in, we're going to create an entity record type in Mesh. So Mesh has the ability to create record types. So we're going to create an entity record type that just holds the ID. Won't really hold any other information right now because the ID is really the most pertinent piece of information for a single entity. Because like I said, component information is stored elsewhere. So instead of just passing a number around, we're going to have an actual type to do, basic type checking if we need to, and to make things a little bit more well organized. Then we'll also create a system record to hold system definition. So a system definition is really only to encapsulate functionality. So it would have, right now, probably just an update function. So you would create a system record, or an instance of a system record to say, here's a system and here's the update function for that system. And that system may contain other information later if we decide to add it. So it's just something we're going to do for now until we get a little bit further with the design. Also, create a physical component to hold position, size, and other physics attributes. So this is sort of like the positioning of the game object in the world, and we're going to have that be a separate component. Also, a renderable component for sprite rendering. So basically saying, here's a texture, then go render it, but you also have to somehow reference the physical component as well to get the position. So we're going to have to figure out how to do that as well when the time comes. And then we're going to create the renderable system that is able to draw all of the renderable components. So that's what we're going to start with for now. We're going to cheat a little bit probably in certain places because, maybe we don't have all the language features necessary, or maybe we can't really do the perfect design just yet, but we'll add to it over time, like I always say. Okay, so first of all, let's look into adding that object array type. And feel free to ask questions anytime if you have questions about what I'm doing or anything else in particular. All right, so let's go into, whoa, how did I get there? All right, so object, it's not giving me access to the compiler files. Okay, so let's go into compiler/source/object.c. Now, in fact, let's go into object.h to start there. So up here around object cons, we'll just start with this. We'll paste that in and make an object array type. And this is going to be pretty simple because all we got to do is just pull in the value array that we already have. So we have an internal type called value array that can store a dynamically sized array of values. So we can just say objects here, I suppose. And that's probably good enough to get started. I don't think we need anything else there. So what we'll need next is a function that can make one of these. This is actually going to be pretty easy because it's not really a complicated type. So that's a good thing. So object array, object make array. Eventually, I'm going to move all this stuff around as well because I think the way that all these functions for these types are sort of slammed into one module, I don't really like that too much. So we're going to move them around. But right now, we're not going to do that. Okay, so we have object array here. We also need to go into value.h and then add the type def for that type. So we're going to copy the object cons line and we're going to say object array and then object array here. And that should be enough to get the basics off the ground. Oh, we also need to make the implementation of the make array function. So I'm going to go into object.c, make const. We'll go right below this function. We'll drop that in. And then we'll just do a little quick copy on this as well. Object array, alloc object, object array. We also need to add the object kind for array, which I haven't done yet. And array arrow objects, we need to initialize this. So I think it's mesh value array init. So we're going to initialize the array objects to make sure that it actually, you know, has an initial array to deal with. And then we'll go back to object.h and go to the object kinds list and then copy this one down here and then make it an object kind array. All right, so that should be enough to get object array working. Let's see, what did I mess up here? 105 in object.h. Ah. Oh, what? Oh, semicolon? Is that what it is? Ah, okay. Is that all? Okay, one last thing in object.c, line 160. Incompatible type. Oh, this probably needs to be an ampersand there. Let me double check that I didn't. Yeah, okay, that's right. So this is not a pointer. This is actually a struct value. Oh boy, we got some spammers on Twitch. Great. Okay, so try to recompile. It looks like that worked. Ignore the memory leak discussion here. Function keyword add. Now, I wonder if I've got any problems here. Oh, only functions can be called receive kind 8. Let me also, okay, I forgot a couple other things I need to do in object.c. I need to add the ability to print that it's an array. So where is the cons? So we're going to do this right here. Array break. And we can say array p. We basically just want to put a pointer to the array object itself, because we're not going to put any information about the object. We could say how many objects are in there. That might be kind of useful, but we'll leave it for now. It says value correct. Why don't you like that? Argument has type value. Oh, interesting. Oh, okay, so here's what we'll do. As object, yeah. We'll get the actual object pointer. That should be sufficient. All right. Hey, Luis. Okay, so we got that in. There's something else that's wrong also, but I don't exactly know what it is. I don't know what it is yet. So we'll go back up here. This is the free function that can deallocate an array or any other object type. So we're going to put an array here, object array. We also need to get a handle on the array itself so we can free it. So let's do this. Object array equals object array. Yeah, object. Is that right? Yeah. And then mesh value array free. What? I think it's free. My IntelliSense or my code completions are not working very well right now. Okay, let me double check that. So in value.h, value array free, and it needs the memory object at the same time. What do I have passed in here? This is VM. Okay, so we'll cast that to mesh memory. VM and then array. All right, so let's just try this again. Undefined, oops, little typo there. All right, we still have a problem. Load module, parse, lambda inner, memory alloc. You detected a memory leak. Only functions can be called line 6 in script. Okay, so something's wrong here. Only functions can be called. Something is, oh, you know what? I bet money it's the headers are sort of out of whack. Let me go to vterm and rmrf bin. I got a pretty good idea that this is just a an uncleanliness issue in the compilation output. Oh, it's still happening. That is really interesting. Oh, only functions can be called. Did I not recompile the compiler correctly? Okay, that's... Oh, let's go to vterm. ls bin. Okay, so the compiler probably has out-of-date stuff too. So let's go to the compiler folder, rmrf bin. Okay, so let's go back down and then we'll run this one more time. Okay, I think that did it. All right, so now we've got everything rendering again. As you can see, there is a tile here. It's very small because of the resolution size that I have for the screen. But let me just go tweak that so we can actually see what's going on. I'm going to go into renderer.c, I think. Let's see, go back to main, renderer, and then scale, I think. Yeah, let's change this right here to maybe 2. I don't know if that's going to be too big. We'll take a look at it and see. I'm going to do some auto scaling at some point so it's easier to track the size of things. But you can see now that we have one tile for the game rendering on the screen, which is great. It's a good sign. And then we now should have the ability to create arrays. So we're going to try that in a moment. What we don't have, though, is an API for managing arrays inside of mesh code. So if I go into, let's see, I need to go into the mesh code, compiler / modules mesh. We can call it array, I guess, array.msc. Define module mesh array. And then, so we need some native function that will help us to create an instance of an array, which is not a problem. So let's see. I'm trying to think if we can just expose it directly. And then we'll need a function called array push, which will take the array and the object or value to push into it. And even that might be defined in native code. So maybe both of these functions are here. Let's delete that for now. We'll come back to that if we have to. Maybe it's just all native functions here. So we'll go to compiler / source / we're going to create an array.c. I think we're going to need that. So if I go to, what else was it? Module. Let me check out what I did in module.h. Since this is a similar kind of concept. Array.c, array.h. All right, so we'll just delete these. Array. Object VM. Okay, so mesh array. We already have a function for that, but let's see. Array make MSC, and we'll steal the parameters to, let's see, which one would it be? Process. Yes. Okay, let's just steal. Actually, let's steal the whole signature here. So we're going to put value in the front, and then we're also going to steal these arguments as well. Drop them right here. And that should be good enough. And then value mesh array push. And we'll just steal the same things again. All right. So both of these functions now need to be defined in array.c. Array.c. We'll save that file really quickly. We're going to include array.h. Nothing that complicated here. All right, so now let's expand these two function definitions out. Okay. Oh, I forgot also to... We probably need two versions of this. We need one that's for mesh code and one that's actually just a normal push function. So, in fact, both these could probably have similar arguments, but for now, we'll say object array. Come on, object array, value, value. All right. Thanks, Ashraz. Okay, let me do something real quick. All right, so pushing to the array. I think we're gonna call into. Let's see, let's pull up include value.h because it has one of the functions we need for this. And then we're going to call, I'm seeing now that I need to sort of simplify this design because I've got two different ways to call into the same code, but we'll deal with that another time. Mesh value array right. That's the one right there. Mem array arrow array, and then the value. So it's basically just wrapping that same function, but it will unwrap the object array to be an array. Now this, no member named array in, okay, this is actually objects. All right. And maybe it should also be an ampersand. Hey, Ashraz. Well, you know, you can catch spammers and not chat if you have to pay attention to a meeting. I appreciate your help. Okay, so mesh array push. Also, we will maybe return the value. This is a way to sort of pass it through. That might be useful. I don't know if it's really that useful. And in this case, we are going to, let me grab some validation from another, function, because I need to standardize this, but I just haven't done it yet. So I want 2 parameters here. Function requires 2 parameters. We're just adding that there in case someone tries to call it with the wrong number of parameters. And then what we'll do is return, let's see. So args1 value is args1. Return value. It seems a little bit wasteful because it's doing copies on those. Excuse me. Object array equals args0. We're not really checking that these are the right types, but it doesn't matter too much. And then we can also call mesh array push array. Well, we also need to have the mem array and then the value here. And I didn't really need to create arguments for those, but I thought it might be, you know, kind of useful. And we need as array here, which we have not created the macro for that yet, but we will. I think that is fine as it is. So let me go to object.h as cons. Okay, so let's copy these 2 here and then change the names. Array is array as array. Then object array. And then object kind array. So now we have the ability to extract the arrays from a value. That should be enough for that. Now we need to do the function for creating an array. So return object val array. I'm just sort of going backwards a little bit here. Object array equals mesh object make array VM star. I see that this is not ideal, but okay, I'm gonna stop complaining about what I've done so far. Okay, so I think we're good on that one. We just need to create an instance of the array and return it wrapped in a value. So I'll take this also. What don't you like here? Conflicting types. Okay, let me go into array.h. And I'm going to drop this here, and then I'm going to drop this right here, or MSC. Okay, and I think that should get it settled. Yeah, Ashra says, given you have a kind check, maybe you want to add an assertion in your as macros to check whether the object really is the correct type. Probably I do, but yeah, I'll add that later for sure. We need to be able to check those and make sure that we're not violating any assumptions. Okay, is there something wrong here? Oh, I made this a star. What? Push. Passing value to pointer of incompatible type value star. What? Did I put that wrong in the header? No. That's confusing. Parameter of type int. I think CCLS is bugging out. All right. Click. vterm is doing some really strange things lately, and it's kind of annoying me. Okay, so we're going to go back to the compilation buffer. All right. So we'll just try to compile it. Seems fine. Okay, it's not upset. All right, so now that we've got that working, we can try to create an array in mesh code. So let's just try that out really quickly and see what happens. We're going to go into main.msc and we're going to define an array, define test array. I probably should write a unit test for this. Make array, which now remember I haven't created the bindings, native bindings yet. So test array, array push test array 1, 2. I also need a function to reference an index of an array, and then display test array, display new line. I also added string escaping support, so now we actually have real new lines in text, which is good. Okay, so we're going to try that out. We also need to go back into mesh. No, let's see. Array vm.c. And then inside the register function, we need to register the array functions. And then what we're going to do here is make array, mesh array make, and then mesh array push. Okay, so array push. That should be enough to get those in there. Also need to go up here and add array as something we were pulling in. Include array.h. All right, so now let's give it a shot and see what happens. Okay, undefined reference. I haven't even built that code yet. Fantastic. Let's go in here. We need to add it here as well. So after list, we'll just add array. How about that? Okay, undefined reference to panic. Let's go into array.c. We're going to add util.h. Come on now. Okay, so we got a little crashy here. Let's see what happened after all this output. Undefined variable make array. That can't be right. Oh, did I not? Main.msc. I did not pull in mesh array. Okay, that makes sense. So let's do that. Mesh array. We'll go back and tidy these up. No. You're going right there. Okay. Come on. Compile. Let's go. Okay, so I think it's okay. The array print worked. And now what is this complaint? Use after free. Okay, fine. Cool. So at least it does get created correctly. Let me double check. What did I just see that I need to fix? I need to go fix the print function. Object.c. Go right in here. I need to add some brackets around this because this is an object. Yeah, Abaddon, you're not too late. We're only about 30 minutes into it. Okay, so good. We're at a point now where we have an array type working, so we can cross that one off the list. We'll tweak it if we need to. And then next thing is to create a entity record to store the ID for entities. So that's much, much easier than what we just did. So we're going to go back into the source for crash to stack. We're going to go into Substratic. And we can just say entity.msc here. Excuse me. Define module substratic entity, this is going to be like the simplest code ever. So internally, we're going to have an entity count that does not get exported. So entity count, we're going to start that off at 0. Then we're going to define a function entity create, I suppose you could say. And really doesn't do anything yet. I could think about it having a set of components, but I don't know yet what the right approach is for doing an entity creation function. So that's one thing I hadn't considered yet. But at least for now, here's what we're going to do. Oh, yeah, okay. Set entity count plus 1. And then we want to return entity count. Let's see if the language can tolerate such a simple bit of code here. I hope it does. All right, so then we're going to go back into main.msc. I'll just comment this stuff out for right now. And then we can say define my entity, create, and then display the first entity is display entity create. I don't have a format function yet, so that's why I'm doing everything on individual print functions. Entity, and then display new line. We also need to pull in substratic entity here. All right, so something crashed. Let's see what happened. Oh, okay. Undefined variable entity create. That's, oh, I didn't export it. That's why. So the fact that I'm actually, you know, not exporting things by default catches me often. Okay, first entity is 1. How about this? We'll double check that too. So let's see. Entity ID. And we'll just have a little fun here. Let's just do this. Boom, boom, boom. Make sure that it's holding the state of how many entities we've created so far. And just see what happens. Oh, unexpected token kind 2. What did I do wrong? Oh, right here. Good, my compiler caught that. Okay, so 1, 2, 3, 4. Cool. So it is maintaining that state. We have the entity IDs being created. Not certain about this language here, but we'll go with it for now. Oh, the other thing I said I wanted to do was create a record type. So, that's interesting. I have a little bit of a conflict here. Okay, so let's do this. Define a record type entity. Let me turn on scheme mode. Fields ID. That's the only field we have. All right. So now we still want entity count, but when we call entity create, we're going to call into the maker function, and I'm calling that make, I think. So return make entity ID is entity count. All right, so that should do it. So let's see what happens here. Okay, record entity. So we have 4 of those now. Great. So I think that should be enough. Obviously, I'm not writing out what the entity ID is. I could do that. Let's try that. Entity ID, since the record type creates functions for accessing all of the fields and exports those, we can just call entity ID for that. All right. Clean this up a little bit. Just throw a little vertical cursor. All right, let's try that now. Okay, cool. So we do have the right numbers. Good. So at least we have some level of sanity in the language, and I'm not just blowing smoke when I say that this stuff works. Let's go back to our list here. So we got the entity record type done. Now let's create the system record type. I'm starting to wonder if this stuff should be broken across multiple files like this, but we'll keep going, see what happens. All right, so back to entity. We're going to create instead system.msc, define module substratic system. Maybe we want to have entity imported. Let's pull in scheme mode here. Yeah. Let's see, import substratic entity. May not be entirely necessary, but we'll go with that for now. All right, define record type system. Fields, updater. So we need we need a way to store the updater function for a given system type definition. So that's what we're doing here. We're just gonna say there's an updater field that you pass a function into, and that can be used to call that. And that's pretty much it for that, I think. So the next thing we want to do is So we'll just call that done for now. So maybe we'll go a little bit backwards. Let's start by creating the renderable system. I wonder, should I create a subfolder here for some of the... Oh, no. Yeah. Create a subfolder for some of the existing systems. Because there's like components that are needed and also systems that are needed. So maybe let's just try that. Let's go... Let me check one thing really quickly. Okay, make sure that we're not escaping this playlist. Okay, good. All right, so we're going to go to substratic/systems/renderable.msc. Save the file to make that directory. Define module substratic systems renderable. Turn on scheme mode. Import substratic system, which I know seems a little bit ridiculous. I may just rename it to systems and then have that be like sort of the top level import, which I don't really have the support for yet, but we will add it if we need to. Okay, so now let's see, make system renderable system. I think that's what I want to call it, right? And then updater renderable update. We also need a define for that renderable update. Now, the great question is, what do you pass into this thing? I don't know yet. So display renderable is updating. Oh, I can actually just do a new line here. Nothing fancy. Okay, so renderable update gets passed into the updater function for the renderable system. Ooh. Make system. No. I need to define this. Define renderable system. And I want it to be that. And I also want to export it. Export syntax is a little bit clumsy for variables, but that's okay. So now that should export this renderable system, which then makes it usable in other places. So what we could do is go back to main.msc and then pull in, substratic systems renderable. And then inside of the game loop, we could just try system updater renderable system. We can actually just invoke that directly. So this, if you haven't seen much scheme, this basically gets the function value out of this record field and then invokes it. So you can pass it in as the first position to a call, and then it should just invoke the function. So we're going to see whether that actually works in just a second. All right, something else wrong. Undefined variable makes system. So if I go back to system.msc, defined record type system. Interesting. In script. Okay, so it must be in renderable, but I'm pulling in substratic system. Make system. Huh. Interesting. I'm gonna have to think about that one. So what if I just clear out this stuff for a second and just say display loaded renderable, just to see what happens, because I'm curious like what the load order of this stuff is and whether it's doing what I expect it to. Let's try that. Yeah, okay, so loaded renderable, that did work. So define renderable system. Excuse me. Make system. So it didn't like make system for some reason, which is very unexpected. Because it should be coming in from substratic system. So how about this? Let's go back. All right, that's still there. Good. Loaded system. Let's just do this. Just to see what order these things are happening in. Loaded system, loaded renderable. So it did actually define that record type for system. Huh. Let's think about this. So define record type automatically exports things. We saw that in entity.msc, make is the name of the function that gets created by a record type for the purpose of creating instances of it. So in renderable.msc, you should be able to see that there is a make system something there bound. So let's try this. Display make system and see if there's anything in that. I mean, obviously it's going to tell us no. How about this? System updater, maybe? System updater. Wonder if I did something wrong in some of the export code. Undefined variable system updater. Okay, that's interesting. So let's do a little surgery in the language then, perhaps. There's two places this could have gone wrong. It's either in the import logic or in the record definition logic. Because it seems that the, well, actually, here's another way to try this out. Let's go into main.msc and call display make entity ID 500. Let's see if it actually does it. Okay, so it didn't get that far because in renderable I'm doing this. So let's back out of that for a second. Okay, so it does print out the entity, so that's interesting. For some reason, I can import the entity maker function here, but for whatever reason, the system maker function is not being exported correctly. Oh, yeah, it's the right module path, substratic system. We don't really need this yet, so what if I just take that out? I don't know if it's gonna make any difference. Yeah, I need to go and reinstate the code that was in renderable, that part. Okay, so it's still broken, it seems. Oh, undefined. Oh, I deleted that code apparently. Let's roll back. There we go, right there. Okay. Whew. That's a subtle little bug. That's very subtle. So I think what happened is because I imported, still doesn't make sense because that's totally valid to import that entity module. Okay, so in system, when I imported substratic entity, it caused a problem. But when I take out that import, problem goes away. So I'm gonna have to investigate that. We're gonna just ignore that for now. It's not doing the print function like I expected. Maybe it's because I commented that out in here. So let's go back here and see if this works now. Should work. We're gonna get spammed. Up. Come on now. Come on. Too much crap. Oh wow. Okay. A lot of stuff there. Undefined variable system updater. This one? Oh, I need to import substratic system. All right. Still problems. Let's see what's going on. Undefined variable renderable system. Did I not export that? I swear I did. Okay, that's weird. Yeah, we do need to disable the leak sanitizer. I could do it myself in just a second, probably. F Society says, can I finally I can join one of these streams too? Are you using ECL? No, I'm writing my own system for this. Okay, so renderable system. Yeah, let's turn that off because it is a little bit annoying. So go to build.sh. Where is the flag for that? F sanitize. So we'll just take that out temporarily, because it is a little bit annoying. vterm we'll rmrf bin and rmrf compiler / bin, then rebuild. Go back to the compilation buffer. Undefined reference. Man, which one is it? Did I not just delete all that stuff? Oh, it's being built. Also annoying. Let's go into... It's kind of nice to have ASAN turned on, but it is a lot of spew at the end. Go to compiler, build.sh. We're going to do the same thing here and just get rid of the fsanitize flag. I need to have this set up a little bit more cleanly. Okay, go back to vterm, do the same thing again. Up. Where's that same line? That's lame. rmrf compiler / bin. Okay. Compilation, build. Okay, there we go. Less spew, good. Undefined variable renderable system. Renderable.msc, renderable system. So I'm making the system, and then I'm exporting it. I'm making a variable to hold the instance of the system record, and then I'm exporting it. I'm pretty sure that this is the right syntax. Otherwise, it would be complaining at me. Let's double check in the compiler. Thought that's the way that I set it up. Source, compiler, and then export. Define attributes. This is in parse lambda inner. Okay, so, whoops. Come on. Parse define attributes. Parse normal expression. Okay, so the attributes come after the expression for the value. That makes sense. Trying to think of why we've got some import issues here, it seems, for sure. So here we needed to import substratic system, which is fine. But when we export this, it seems to not make it to main.msc, which is not what I thought. All of that should work. Let's just double check. Let's see, parse define attributes, define variable ex with define attributes, define attributes, is export. So that should have been done. Interesting. I may have to start looking at the disassembly and see what's going on there. We are still making pretty good time though, I think. Because if we get the updater for renderable working, then we might be able to start adding components that need to be rendered. Okay. So entity ID is it written anywhere? What's this one? Oh, that's a mistake. I thought I could write out display like this, which I can't because I didn't actually implement that code yet. Let's see. Display. It's not really necessary, but I'm going to do it anyway. Oops. Just so I know what I'm looking at. Okay. What about display? Whoops. Display renderable system. I know it's not going to work. Actually, how about what if in renderable I export this function also, just to see if I can see that one. Renderable update. Renderable update. Display renderable update. Okay. Okay, so even that one is not visible. So something is wrong with exporting from in that module. I wonder. This is some timing issue somehow in the module system. All right, so what I'll try is to go into module.c. Excuse me. And here I'll try to write out printf importing into module to module name chars. And then here I can say printf importing symbol, importing exported symbol. We're just going to get a read on what's happening here. Export name chars. So that should be enough for us to see what's happening. Okay, so importing into module crash stack main. Let's say which one we're coming from to. From S, from module name chars. All right. Segmentation fault. That's not a great sign. From module should be set up already. Name chars. Okay. Very interesting. How far did we get? All right, so into crash the stack main from mesh array. We're pulling in array and push. Okay, good. Main from substratic entity. Into crash the stack main from substratic window. From substratic texture. From substratic renderer. From substratic system. Into substratic systems renderable from substratic system. We see that one happening. All right, so let's go into GDB. GDB. Let's see. Let me make sure I'm getting the right path here. And let's start from the right base folder. This should be the right place to do it. bin/crash the stack. Let's run it, see what happens. Okay, so in the backtrace, module, okay, of course the printf is a problem, but why? Kind of strange. From module seems to have a valid address, but doesn't have a valid name for some reason. So if I were to see, what's the name of that function to step to the frame? I don't know if it's F. Let's see, F to number 3. Okay. So we're in mesh module import from module. Want to print. Probably gonna. Okay, so the name is null. That shouldn't ever happen with a module. Weird. And the module we're going into, to module name is chars. Okay, chars. Whoops. Crash stack main. So we're importing something. So at this point, it must be. What was it before? Importing into module substratic systems renderable from substratic system. Oh, you know what? After this could be a timing issue. The reason why I say that is because the bodies, the bodies of these modules are being executed after the current code is finished executing. Unless I'm pushing that on and executing them immediately. Okay, I'm gonna have to look at the what the VM is doing, I think. For a couple of reasons. So let's go into vm.c and then turn on trace execution, go back. Okay, we're in the compilation buffer, so let's do that right here. This is gonna be a nice little mess to look at. Probably should turn on the compiler trace also so that we can look at this in a more sane way, because we're just looking at the value stack, which is pretty deep at this point. Need a better debugging experience. Come on. Go to the top. There you go. All right, so first of all, we compile the main... well, we also got some auxiliary files here as well, which are not really useful to look at. Substratic texture, we're compiling. It must be... okay, so this is definitely in the main script file. Renderer clear, renderer draw texture, blah, blah, blah. Yep, that's the main file. Crash stack main. Okay, so we're defining the module of main. Why is this happening twice? Oh, that's the body. That's the let body. Okay, so that's just the let body being compiled. Interesting. Yeah, that makes sense. Okay. And then we're compiling the script file itself, where we see we're defining the module for crash stack main, importing mesh array, importing substratic entity, window, texture, renderer, system. All right. And at this point, we start executing. So define the module. Okay, we're doing an import now. We're importing mesh array. Importing into module. Got those two exports. All right, so now that we sort of have our bearings, we can skip ahead a little bit. But we can see here that it does go ahead and pull that module in. So it loads it and executes the code of the module, or at least it seems to immediately, I think. Yep. Okay, so it's defining substratic entity. Define record, define global entity create, export symbol entity create. Okay, so that's it for that one. So we're importing the newly created module into crash stack. We imported the three symbols that were there. Okay, so that's window. Let's skip that a little bit. Texture, renderer. Okay, so here's substratic system. All right, so who's resolving that? Crash stack main from substratic renderer. Okay, so this has already been done. Okay, fine. And this is substratic system being loaded. Define record. Substratic system. Define module. Okay. Display. Okay, we defined the record for system now. We have that coming back out. Hold on. Okay, we don't get any explicit export instructions because record takes care of that. And now it seems that those are being pulled out of that into crash the stack, but there's something else missing here. So now we're pulling in substratic systems, renderable, resolve module. Okay, so that's the actual code. Function renderable update. We're exporting the symbol renderable update. And we're also exporting the symbol renderable system. So that all is executing correctly. And this is defining the module. Blah, blah, blah. Okay, so here's where we're importing into from substratic system into the renderable module. So it seems to be pulling in those bindings correctly. And then, all right, we get to all of that. We're exporting the symbol inside of the correct module. Okay, and then finally just imports the module. But that, let's check that out. Import module. Weird. And where's import module picking up the module from? That would explain it. So in vm.c, import module. Okay, pop the result of evaluating the module's body because we don't need it. But it's still not right in this case because there's a script in here. Where the hell did that come from? Okay, so what I'm looking at here is the module that I'm trying to import is right here on the value stack. I mean, it's kind of difficult to read this. Sorry for that. But then there's two other things in front of it. Okay, so we pop the record system off first, but then there's a script here, which shouldn't be there. So I must have made a mistake somehow in this particular execution path. How did that get in there? BO, and then the script shows up. Hey, Emil. Jackson says, what languages do you work with in your day job? I work primarily with TypeScript and JavaScript in my day job. Okay. So I think I've narrowed down what the problem is here. There's something weird going on with the specific execution path. And I've also got a lot of modules that are leaking on the value stack, which should not be there. But maybe that's just sort of a consequence of how things are being loaded. But that does need to be dealt with at some point. So is there any way we can get around this for now? Or figure it out? Does it happen anywhere else, I wonder? So import module. So if we just get rid of the compiler spew, then we can just take a look at all the value output. And then I get a closer look at what's happening with all the import module instances. So here, the module is just below the top of the stack. Same there. Same there. Same there. Same there. Fine. Fine. And then right here, at that specific point in time, it leaves a script on the stack. Now, I think the reason why it must be because that module, well, it hasn't already been loaded, has it? Renderable. Let's see. Oh, okay. Well, of course it's already loaded, and it's executing at this point. Renderable. Okay, so something strange is happening here. Because even at this point, the module is on the value stack twice, which may be normal. I'm not sure. Yeah. How many times? 1, 2. 2 times. Let's see. Let's go back into main. Renderable. Oops, renderable. Yeah, it would have already been imported. Wouldn't it? No. This is the only one that pulls it in so far. We're defining it, and then here we are importing it. Yeah, what is the deal with this one? It doesn't make any sense why this is different. All right. Did not expect to have a detour like this right now, but, you know, it's all in good fun. So now that I'm looking at it, renderable is only there once, okay? So it seems to have popped off two things from the stack at the end. It popped the record off, and then it popped the second instance of the module off. So let's look at the other import module instances. I'm trying to see if this happens often where you have two instances of the same module in the stack, because it seems like there's a bug in there somewhere. Yeah, not there. Window is not twice. Render is not twice. We need to look at resolve module, actually. But resolve is doing the loading. So it's the result of resolve that we're looking at, really. Import module. Let's go back to the end. I want to take a look at that one more time. So substratic system renderable. Okay, that is the line. Oh, there's a return. Okay, hold on a second. There's renderable twice. Okay, so OP return. We should look at that. That's weird. Why is system different? So that's for renderable. Oh, okay. There is one for system also. But it's not on the stack twice. Something really interesting happened here. And it happened earlier. Okay, define global. Let's go back slightly. Constant pop, still there. Still there. Still there. Still there. Okay, resolve module. Okay, so how did it get on the stack twice? It's already here. Oh, the define? Now I'm getting extremely confused. Who's calling that? Okay, yeah. Okay, so we've already got it. And then it does it again. Okay. It's weird that it's happening here. So I think what I'm seeing is that inside of renderable.msc, substratic systems renderable. Same name, right? For some reason, the define module here is causing the module to show up twice on the stack, but it's not doing it for other modules like substratic system. So let's go back up a little bit. How about to write about up. Importing into module from substratic system. Sorry, folks, I'm getting really confused. That's the joys of making your own language. Okay, so let me think if there's anything I can do to skip past this problem for now, because, you know, I don't want to, you know, hold us up too much. Here's what I'll do. I'll define the stuff inside of the main file so we don't have to deal with this problem. And then we'll clean that up. I'll clean it up off stream. I'll figure out what the problem is, because it's still a little bit too annoying for me at the moment. Let's see what happens when I do this. Okay, so we're back to rendering again. Let me turn off the VM debugging so we don't see all the output. Okay, renderable's updating, and then eventually it crashed. Oh, value stack has been popped below initial address. So we have a stack management issue now. That's really funny. Nice issues with the language. Okay, so system updater, renderable system. I wonder if it's the way that I'm calling this. How about this? Let's do, ooh. Yeah. Must be breaking something. Renderable update. Okay. That should just keep running. Wow. And now the angle of the sprite is screwed up. Okay, so at least that works. Something about it, I think this isn't breaking my assumptions for tail call optimization, what I'm doing right here. In fact, how about I go to the compiler? I'm curious to see what gets outputted there, if it's a tail call or not. All right, so I'm calling renderable. Yeah, it's just a call, not a tail call. Oh, yeah. Well, it makes sense it's not a tail call, actually, because it's not in tail position. Yikes. Yeah, that's also a problem for a lot of this stuff, too. Didn't think about that. But it should pop back. So the loop itself is a tail call. So this part shouldn't matter. But it is true that somehow it's busting the stack. I would like to see what that looks like. I know we're getting way off track here. That's my fault, but it's kind of interesting to see what all this is doing. Comment that out. All right. Okay, I want to take a look at the stack output here. So yeah, eventually it just eats the whole stack somehow. And where does that start? Something is popping too many times. Okay, so we're doing some calls here. Every time we call, which function? Game loop. I'm trying to find renderable update. Okay, so every time we call renderable update, what happens? Renderable update. All right, so this is okay, that's a closure. That's the define. We're reading the global somewhere. And then we call it here. So at this point, we start off with a stack that looks like this. Actually, let's do the whole read global just so that we have a clear comparison. I want to like take a look at each instance of the stack after this. Read global renderable update. Okay, wow, that's the only one? Oh, I guess it makes sense. Renderable update. So we call, and then we pop it off the stack once it's done. Renderable is updating. We return. We pop the string. Okay, the string is the result. So this is after, I think. No, that's 104, right? Different function, maybe. 104. Yeah, I'm gonna just take this right here and take a look at it. So texture load, assets, images, updater, renderable update. So it gets rid of a lot of stuff before that. Read global renderer. Shouldn't I do that more than once? Renderable update. Yeah, it keeps eating things. Every time it gets called, it eats one more value in the stack than it's supposed to, it seems. Yeah, it's like cleaning up all those old modules somehow. Okay, so let me think about that. I'm calling the result of another call, which I do want the result from. Call 1. Every time we have a call 1, let's just check it out really quick. Okay, so that's 1. So we call that function. Define global. What? Oof. Gotta love those alert sounds. Let's see. Welcome to Coalfox. Hello. Okay, so what we're doing right now is we're trying to figure out why the language is eating too much of the value stack whenever I'm sort of invoking the result of a function directly. There's something about how I'm doing that causes a problem. So we call it, where is it on the stack? It's going. We're trying to make some progress here, and I keep running into issues with the language that I've written, which is fine. I still haven't tested it thoroughly enough yet, but part of what I'm doing with these streams is testing it. Okay, so pointer, record system, pointer. Where is it? It must be further down. Pointer updater, record system. Okay, so this is where it happens, right here. So there's a call and another call. So this is the call that, which one is the call that does that? So, okay, that's there. First of all, we call system updater. So we're calling system updater to pull out the renderable update. Ashraz is creating songs in the chat here. Every time it happens, it just, you know, takes probably a year or two off my life. I swear I've tweaked that sound and it's still super loud. All right, so the first call returns the renderable update. I think that's what's happening. After the call is done, renderable update's on the stack, and then the next call is using renderable update, which loads the constant, displays it, and then returns. And before, yeah, so it has the function on the stack. Return pops the function off the stack. And then OP pop gets called, which pops the result of the outer call off the stack, which in theory is fine. But I think something else is happening. Let me just examine this one more time a little bit more closely. So we have the record type. We have the field accessor here, the updater. Oh, I wonder if this is a problem with the accessor function. Okay, so we have entity here. That is what it is. It's this stupid accessor function popping one too many things. Okay. Let's go into VM and then object record field. And the accessor function, we're popping twice. Pop the record and the accessor off the stack. Well, that's what we think we're doing. And then we push the value onto the stack. So let's just take a quick look at that really quick. Quick. So here we have the field accessor type and the system. Oh, there's another pop here. Whoops. So that's a problem right there. So we've already popped it off. I probably should peek this and not pop. So let's just use VM peek instead. VM stack peek. Yep, that's a bug for sure. Yes, I think now we're okay. And if I turn the VM debugging off, then at least we've got one bug resolved. Boom. I think this is just spamming now. Great. Excellent. Okay, so that works. Thank God. In fact, let's go ahead and check that little fix in, because that is really a problem. Let's see, remove unnecessary value stack pop when reading record field. Okay, so we want that for sure. All right, good. So now let's go back to main. And now we're at a point where we can finally start trying to manage instances of a particular component. All right, so for a renderable component, we're just going to use a normal field type. A record type for this, because define record type renderable. I wonder if it should be called renderable component. We'll start with that. Fields, texture. Now, this is not exactly renderable, because other things can be rendered that don't have textures, but maybe this is something that we'll just go with at first. I mean, we could say like a sprite component, but that sort of implies a little bit too much, I think. Okay, so renderable component, fields, texture. What else is needed for that? I think that's it for now, just for the renderable part. We also need to have a record physical component. And this one is a bit more interesting. It's going to have fields, X and Y positions. Let's see. Also needs to have a width and a height. You could also have a scale and a rotation. And I think that's good enough for now for our physical component. We're going to use that information for rendering in just one moment. Okay. So we have these two things. And what we could try to do is create an instance of each of them. Now, the other question is, who manages the creation of the lists of these particular component types? So what we really need is, let's see, a define renderable array, make array, okay? We also need a define physical array, or maybe we'll call it a physical component array. That's much better. Make array. Renderable component array. Now we have arrays for both of these, and we could add stuff to them. Also, you know, components really do need to have the entity ID in them. So let's add ID here. Maybe we need to be a little bit more explicit. Entity ID. Makes it a little bit too verbose, but maybe it's better than not being specific enough. So renderable component entity ID. That's a lovely field accessor function name. All right. So we can make a new instance. Let's see, array push. Let's just do this for both. Let's see what happens. Array push, renderable component. Make renderable component. That's what we want. Make renderable component. And then entity ID. Let's also see, did I save that above? This code is getting a little bit messy, but we're going to fix it once we get the module stuff working correctly. Define entity first entity. How about that? Make, or we called it entity create. We got to really get our terminology dialed in here. Okay, so first entity. Probably need constructor functions too, now that I think about it. I'll have to add it to the record implementation. Okay, so we have first entity. That'll have an ID. For this, we're going to say entity ID is an entity ID of first entity. And then texture is, what is it? Tile sprite, I called it. Whoa, too far. Main.msc. Where are you? There you are. Okay. Tile sprite. Okay, so that's our first component instance in the, we also need to say the renderable component array here. Okay, so we've pushed that. We also need to push for the physical component array. Physical component array. Let's move this guy down here, actually. All right, so define our first entity and create some components. Yeah, there needs to be a much cleaner syntax for all this, which we'll figure out in the future. Okay, so now for the physical component array, we want to make a physical component. And we can pull the same ID, the X. I think we were saying 100, 100. Let's make it a little bit more interesting and move it somewhere else so it's obvious that it's not the same place. Y is also 500. Width is the texture width. Do I have a function for that yet? Probably not. Texture width tile sprite. We'll do the same thing for height. Whoa, what just happened here? A little bit of, what the hell? Lispy is just freaking out at the moment. Height. Thank you. Texture height. Okay, we don't need this texture here. The other thing we wanted... We don't need to set the scale yet, the scale or rotation. So we're just going to leave it as is. All right, so that one's good. That's our physical component, our renderable component. They both have the same entity ID registered because we're doing it based on the same entity. And as I mentioned before, entities don't actually contain the components. Those components are listed somewhere else. So you can imagine that this physical component array is something that's stored in the module for a physical component, or a physical system, I guess you could call it. So now for the renderable function, renderable update, since we're actually calling that here. In fact, we might want a list of updater functions, or a list of systems that are active. So how about that? Let's just do this really quickly. Define active systems. We can make that I don't want it to be a list or an array. Doesn't really matter, does it? Possibly a little bit faster as an array. Make array. Array push active systems renderable system. Okay, and then here let execute systems. I is 0. I'm gonna have to add some other functionality for array type in just a moment. So let execute systems, and here we will. Yeah, so array nth, I guess you could say. Active systems I, and then execute systems. Well, we need to do a check on that first, actually. So if I not, yeah, I need to add greater than less than here, obviously. Okay, so not equal I array length active systems. We're just writing a little loop here. So if it's not equal, then we will execute that index. We're going to call it. So we're going to do this. System updater. This is a little bit messy, but let's see how it goes. And we're going to wrap that in a call expression. Call this systems updater. And then we need to recursively invoke execute systems. Or actually, let's do this. We'll do a little bit backwards here. If equal I and length of active systems, then we will exit. Nah. Sorry. We don't need an else case. Just don't call again. Execute systems plus I1. Okay, so that is enough of a recursive loop to run all system updates. Okay, so that is good. Not equal 1. Cool. Begin. That looks good. Now we have active systems. We pushed renderable system onto active systems. We also need to go into array.c and add, we have push, but we need length. So mesh array length. And then we'll just make this be a 1 parameter function. It just needs to take in the array itself. And then we're going to return a number val. Is that right? Of array objects dot count. Okay, I think that's it. That should be good enough. And then we need to roll into the header file, array.h, and add a similar thing there. And then in vm.c, we need to go to array. Where is it? Native functions. Register. Okay, right here. So array length. Array length. Okay. Oh, length. Okay, so array length should be good now. Let's go back and see if there's anything else we need from the code we wrote so far. Array nth. Okay, so we also need the nth function. So let's add one for that too. I don't know if maybe I need array ref. I've used nth somewhere else, so let's just go with nth for now. And then we're going to go back into array.h, array nth. And then go into array.c, array nth. And we're going to pull 2 parameters this time. In fact, let's go here and grab this one instead because it's easier to copy that. And the second value is going to be a number. We're going to say return array objects values. Now that, yeah, that's right. Okay, values. And we're going to grab the index from this value here as number value. That's going to give us an array indexer to get the specific item out of the array. And we don't need to call that push function. Okay, so array nth, I think we've got that back in VM now, array nth. Okay, that's good. Let's see if we can run the code. Okay, there's a problem here. Array subscript is not an integer. Yeah, we want to cast that down to an int because it's a float, I think, or a double int. Okay, unexpected token kind. I must have made a mistake in my source somewhere here. Doesn't tell me what line though. So that's okay. That's okay. I wonder if it's expecting an else case and I'm not giving it one. Okay. Let's just do that. All right, so display done with system. It's probably gonna work. I need to go fix that code. Don't know how to free object kind. Which one? Oh, texture width. I gotta go add those two. Texture. Let's see. Nope, that's definitely the wrong texture file. Texture.c. Is this the right? No, that's the wrong file. Okay, texture.c. Yeah, all right, and texture.h. Okay, so we need to have, that's fine right there too. Texture width and texture height. Texture width and texture height. We're gonna copy both of these, go back into texture.c, jump to the bottom, drop these in. So we just need to have a 1 parameter input that grabs the texture. So we'll say 1 here, function requires 1 parameter. And then we're gonna say object subst texture. In fact, we can just do that. Let's see, subst. No, this is from a pointer, subst texture star as pointer args 0 pointer. That's right. Okay, and then return number val texture width. All right, and the same thing for height. So long as this doesn't actually crash. I don't know if this is going to be sound code. All right, so we're going to grab height here. Height. Then we're going to go into this function up here to add those to be registered. So texture width, texture height. Whoops. One too many. Width. Texture width. Texture height. Height. All right, cool. I'll just put those there because I like them a little bit higher. Okay, let's see. Interesting. This is rendering funny. Done with systems renderable is updating. Okay, so that loop for the systems is working. Let's see. Hey, Fade. Okay, so also it is calling the renderable update function, which is a good sign. We kind of want it to not display something now. We actually want it to render something, so. Sorry, sneeze coming on. Excuse me. So we're almost there. We're almost at least to something that is working correctly. So let's try to hit it in the next 10 minutes. I don't want to do this display, so I'm just going to return a bogus value, and I'm going to remind myself to clean that up. To do else case should not be necessary. And also in the renderable function, we're going to render something now. We're not going to just print garbage. Texture render. Renderer draw texture. Okay. So we're going to take this little snippet of code here and drop it into the updater function. So I'm going to drop that right here and delete that part. So now let's just return T. I want to do something really quickly just to make sure that this is doing what we expect. So now nothing should be getting printed every frame, and nothing should be, the tile should not be getting rendered at this moment because I've turned off that code. Okay, so yes, exactly what I expected, which is good. Now if I go back and add this code, every frame it will render this one static tile sprite. Okay, and it's doing that freaky thing again. Let me check render draw texture because I think something wrong is happening there. Draw texture. Am I not initializing the draw args? Draw texture MSC init. Okay. Am I scaling it there too? Shouldn't be doing that. Wow. Okay. Draw args init. Shader program. I swear. Not very smart. Flags equals 0. That should be every single time. Okay, let's make sure that tile's rendering correctly now. Okay, yeah, that was a problem. Uninitialized struct members, great. So now, let's do this. We're gonna go back to main.msc. It really would be nice to have more than one entity render for this. So maybe what we can do is define a little function, make tile. This is what we're gonna do. This will at least allow us to validate things really quickly and make sure that we're not just, you know, BSing our way through this whole exercise. Texture. All right, let's do this. So we're gonna do both of these things, this array push on both of these things as well. Now, I'm gonna do a let here, entity, entity create. And then at the end, I'm gonna return the entity, though we're probably just gonna throw that away. So here we don't need first entity. Ooh, we're gonna have a little conflict with the struct type. Maybe not. Let's see what happens. I'm curious. Okay. Here we will say texture. Oh boy. Got some Akira related things again. Okay. And here we need to change these two things. This needs to be texture. Texture. Cool. This should be good. So now we can make a tile. We also don't need this. Or actually, we'll move it. How about this right here? Since we don't need to store these, we can just... Yeah, that'll be fine. We will just call make tile a couple times. So there's one at 200, 200, tile sprite. How about this? Let's add 5 tiles. 300, 400, 500, 600. So that adds 5 tiles. And let's see if we can actually get them to show up on the screen. Now, the positions are not going to be wired up yet, but at least we can get them rendering 5 times, maybe. In the updater, we're going to need to have access to the component array. So we're going to move this up here. Probably not necessary, but we'll do it that way. Let render and I is 0. We're going to do a similar thing as what we did before. If not equal I array length renderable component array. That's the next one. Okay. So at this point, we're going to say begin. And we're going to render the texture at that location, or the texture for that particular entity. So render or draw texture. In fact, we can just copy this little guy here. Drop it right there. Delete those. Now we have the renderer, and we want to take the texture from the particular entry. So array nth I of the renderable component array. I probably need to throw a let in here, honestly. This is going to be item. This is going to test the limits of things, I think, which is good. Let's get this guy here. So the array nth. There's probably a better way to do this too. Yeah. As we're looping, we probably should be just picking items out every time. Okay, array nth, renderable component array I. We have item now. And then we want to have renderable component texture item. Okay, we'll just leave the position the way it is right now because we don't have the position for that entity yet, which we can try to get in a moment. And then we'll say display rendering entity, display entity renderable component entity ID item, display. This is horrible. Display /n. Okay. So that should give us a readout on what we're rendering, and it's going to be horrifying to see all that come through. And we also, at the very end, we need to iterate render plus I1. And then also we need to not forget to put a nil here so that it doesn't break the compiler. With display macro required. I haven't seen that particular macro yet. Okay, so expected 1 arguments but got 0. Which one do you not like? Really useful. Expected 1 arguments but got 0. Array length. Line 42. Oh, okay. 42 entity create. That doesn't need anything. Array push, physical component array, entity ID. No, mesh does not have macros yet. I started working on it this weekend, but I didn't make much progress. I'm trying to follow Scheme's syntax style of macros, and it requires me to sort of rethink a little bit of what I'm doing in the compiler to enable it in a single pass approach. Let's see, which one is having a problem here? It's hard to tell. Array push, entity create. Hygienic macros are tricky. Yeah, it's not perfect, that's for sure. I mean, I could definitely make non-hygienic or unhygienic macros easier. Now, I might do that, but I wanted to try the other one first. Okay, so entity create. This is weird. I really need some better errors. 42. Run it one more time. I know. Expected 1 arguments but got 0. Oh, huh. That's in a callable. Entity create doesn't expect a parameter, but let's go look at entity.msc. Make entity count, set entity count. Okay. And this is in VM. Expected 1 arguments, but got, okay, so this is in call. So that tells me that it's an actual function definition that I'm calling incorrectly somewhere in main.msc. Let me double check what I did before here. So this all should be working right, I think. So we did see that happening before. Maybe in this part. Array length, array nth, render component entity ID, render component texture, display. Hey, gun. Okay. So make tile takes 3 parameters, which I'm providing here. Line 42. It's really weird. Display hello. Do we even get into make tile, I wonder? Okay, seems we got into it. Display made tile. Did it even get 1 done? No. So something inside of make tile. Array push. Well, let's see. What if I take out both of these array push calls? Uh-huh. So is it this? Somehow it doesn't like me returning entity. Oh. That's not cool. It has to be inside the let. So does that fix it? That's funny. Okay. So apparently it's just a bad positioning of that last symbol. But that's not a good sign, though, because that was a really bad error. It's very unclear. Okay. What? Still? Almost there, folks. All right, let's comment these out again, because I'm very confused about why this is a problem. All right, so we did inside let, blah 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 blah. Entity ID is 6. Entity ID, we don't need this guy anymore. We also don't need this anymore. Huh. All right, let's try one at a time and see which one of these is the culprit. Expect 1 arguments but got 0. I wonder if it's, well, can't be really, because this is a natively defined function. This is a record accessor. These are 2 native functions. Make physical component. That's also a record creator function. Oh. What about entity, make entity ID 1? I'm just being skeptical of everything at this point. Okay, that's not it. Let's simplify things. Array push T. Let's try that. Oh, I forgot, yeah, forgot to put entity back. There we go. Okay, so something about make physical component is problematic. So what if I, oops. What if I do this without adding anything? We're just gonna make it a completely blank component. All right, so that, it didn't like that. Make physical component. I define a record type for physical component. Entity ID, did I put something wrong in there? No. Entity ID 1. Inside let. Display finished let. All right, I got to finish up on the stream in just a moment. That's very interesting. Something here is not happy. Something about this record record creation type. Physical component. It should be make physical component, and we should be able to pass in whatever we want. Unless it's not resolving it correctly. Oh, whoops, that's wrong. Okay, so that works. Cool. Let's dial back to what we were doing before then. We'll put that back in. I'll insert a parenthesis here. All right, so these two are probably fine. It must be these texture functions. It's gonna really upset me if that's what it is. Okay, let's try the next one, which is texture width texture. Okay. Now go into texture.c. So this is not... Something's wrong. Texture width. Inside texture width with my perfect spelling. Never gets in there. So here texture width is calling texture width MSC. It's in substratic texture. Yeah, something is going wrong here. I wonder if it's how I'm invoking this. Let's do this. I'm just curious if this is going to work. Width texture, width, texture. And then here we will say width instead. I don't know if it's like the inline call there. That's the problem. Aha. So then let's do the same thing for height. And if this fixes it, then we're going to have to do some more work off stream probably to diagnose. I got like 3 different issues that I'm seeing here that are problematic. Whoops, too far. All right, so height. And then we can join that line together. All right, and then we'll run it one time, make sure it works. Oh, I think I broke the code. Array push, let. That one needs to not be there, so if I delete it, it's gonna screw it up. Here, I'll delete this external one. Okay, whoop. Nope. That's fine. That works. Now on this one, let's just see if this one works without any additional tweaking. Same problem. Texture is passed in as a parameter. Something about invoking or having texture in here is causing an issue. So, because it's a local, is that why? I think I know now why. So to investigate why locals have trouble being used as parameters to record accessors or record constructors. Okay. Well, let's leave that for 1 second. Thanks, Ashraz. We're gonna do this. Lispy, give me a break. Text, texture. This is not the way I want to live my life, but we're just going to do this and verify that the local is a problem. Yeah, the local is a problem. Very, very interesting. Okay, so inside let, we're going to get rid of these displays. And we're not seeing any output about rendering just yet, even though we should have 5 tile entries. The last thing I'll do is check the renderable update function, display array. Let's see, there are renderable component count, display array length, renderable component array, and then display new line. Let's just see how many are there. Every frame. 5, okay. So it never gets into rendering the entity. If not equal I. Yeah, it just never gets in there. Okay, something's wrong here, but we'll figure it out. All right, folks. That's going to have to be it for today. But we did make some progress. It wasn't perfect because there's a few different problems with the language. But I think that once I am able to fix these, then we will be well on our way to having an entity component system that works for the purpose of the game that we're going to be making. And then we can continue to add functionality to the engine for rendering of tiles, setting up the game board, and then interacting with it by clicking on things, because the clicking functionality can just be another component that gets added and can handle that input. So we should be able to start making some good progress soon once I get these problems fixed. And then maybe on Thursday, when we get to the next stream, we will be able to make some forward progress into writing the actual game logic using ECS. So thanks a lot, folks, for being here today. I really appreciate your time and attention here. And until next time, keep it creative. We'll see ya.